Hi, everybody. Today, we need to finish what we started in section 7.1. So we ended here, right? So we spent last class talking about solving triangles. And these solving triangle problems fell into like two categories, whether you had a right triangle or not. If you had a right triangle, then we can just use SOHCAHTOA. And depending on whether you're given starting with two sides or two angles, you can solve the triangle using just your regular trig functions or your inverse trig function. If you're not given a right triangle, we were introduced to these two concepts, the law of sines and cosines. And we talked about, okay, depending on which starting information you're given, when to use the law of sines and the law of cosines. So if you're given an angle-angle-side, angle-side-angle, or side-side-angle situation, you're going to use the law of sines. And if you're given a side-side-side or a side-angle-side, you're going to use the law of cosines. And we noted here in our little diagram to tell us what to do, that the SSA and SSS cases have a couple of checks that we have to do before we get started, because some of these problems aren't possible depending on what we're given. Okay, so far so good? So what I want to do now is today we're going to look at doing some examples in the angle-angle-side and angle-side-angle situation, using law of sines to do that. And then time permitting, we're going to start to deal with this SSA case, which is probably the most difficult situation for the chapter. Okay? Are we ready? We feel like we're back on track of where we left off. So let's say we're given that angle A is 32 degrees, angle B is 73 degrees, and side C is 13. First thing that I'm going to want to do is I want to start by drawing a picture and labeling it to describe the situation. When I do this, all of my triangles are going to look exactly the same. Nothing I'm going to do is to scale. I don't care about scale. In your drawings, I don't care about scale. Everybody's all right with that? Do you know what I mean by to scale? Is that angle A and angle B are definitely different angle measures in the picture. They don't look like they're different. That's what I mean by not to scale. Everybody's all right? Then I'm going to add in my, before I add in what I'm given, I need to label my sides. How do we label the sides again? Remember, there's a specific way we have to do this. Good. Side A has to be opposite angle A. So here's angle A. Opposite angle A. Side B has to be opposite angle B. And and side C has to be opposite angle C. Everybody's good? Now we'll write in the givens. Does that look good to everybody? Now I'm going to ask, what situation are we in? Not side angle side, because we're only given two angles. Angle side angle, yes. So, because it's an angle side angle situation, I know I'm going to be using the law of sines. Everybody feel all right there? Okay. And again, if you don't remember, the law of sines is sine of angle A over side A equals sine of angle B over side B is equal to sine of angle C over side C. Feel all right? Now, because all three of these ratios are written equal to each other, I could write sine of angle A over side A equals sine of angle C over side C, right? If all three of them are equal, I can kind of just pick and choose whichever ones and set each one's equal to each other, right? Everybody's good with that? All right. So, to solve this triangle, I'm going to need to find angle C, need to find side A, and we need to find side B. So those are the three things I'm going to need to answer before I'm finished. What's going to be the easiest thing to start with? Angle C, very good. How do I find angle C? Great. I think that gives me 75. Right, 180 minus 105. Yeah. Nick.
So, why did you get the 73? You just put both angles in there.
Yes, perfect. Yes, 100%. All right. Now let's find one of the side lengths. Does it matter which one we try for first, angle or side A or side B? In these angle side angle and angle angle side, it doesn't matter the order you do things. Some of the other situations it does, but these two that we're going to start with, the order does not matter. So let's go alphabetical. We'll find side A next. Sound good? So what I'm going to need to do is I need to look at my law of sines here. The first thing I'm going to need is going to figure out which one do I have both the angle and the side for. Angle A, side A. Obviously not, because I'm solving for side A. Angle B and side B, or angle C and side C. Which one do I have both of?
C.
C. Right, because we just found that this was 75 here. So that's going to be my start. So I'm going to write sine of 75 over 13 is equal to, and then I'm going to use, if I'm looking for side A, I need sine of angle A over side A. Angle A is 32. And I'm going to scroll up here, so I'm done with the picture. Is everybody on board with how I've come up with this equation? So this equation, I have one fraction equal to another fraction, right? Does everybody remember the name for this type of an equation where I have one fraction equal to another? Used it all the time in geometry. It's Starts with a P. Proportion. These are our proportions. Does anybody remember the technique we used to solve a proportion?
Don't you just multiply? Isn't it like the butterfly method?
Yeah, so cross multiplication. This is when cross multiplication comes in. Not when we multiply fractions. It's when we solve a proportion. Okay? So I'm going to have A times sine 75 equals 13 times sine 32. So far, so good, right? What have we accomplished? We got rid of the fractions. That's all we really did. What's our goal still when solving here? We want to get A by itself. So what is happening to A right now?
It's being multiplied.
It's being multiplied. So to get A by itself, we're going to have to divide specifically by? Excellent. By sine of 75. What time is it now? Calculator time. Yeah, let's grab that guy. Okay. So we had 13 times sine 75 divided by sine 32, I think. So I got